We already talked about how conceptually a robot level or higher level control happens. But now let's look at some of the hardware elements that are needed. So let's do a hardware schematic showing some of these key elements. And before I draw the diagram, let me make a list of some of the most typical components used in hardware control for a robot. So you have typically, and this may vary from example to example, but typically you will have microcontrollers where you program the logic for the control. You have motor drivers. Now I believe anybody who doesn't have an electrical background, motor drivers is a mystery, right? Why do you need motor drivers? Any of you know? So we'll talk about that later. Let me keep it a suspense for the time being. Then you would have, of course, your motors. You would have sensors. You would have power supply, and oftentimes integrated with motors you would have other components. Sometimes you have gearbox, or quite often you have gearbox. You would have encoders, and you would have current sensors, many times integrated within motors. Okay, now let's see in a schematic how these components typically work together. So let me go back to having a motor. Now remember, this is not a control block diagram, so I'm not just showing a flow of information, but I'm also now starting to see if we can represent how some of the hardware components work together and what sort of connections they will have with each other. So I would say a motor, then, and in a robot there are typically several motors. This is physically connected to a robot. So I'm showing this in a slightly different way. This physical connection I'm representing by a thick blue line, and this motor is typically receiving two wires, right? And connected across these wires is also a current sensor, and from these two wires you are reading the current. Let me draw this bigger. And we already talked about in the control loop that current sensor is used in PI control, but here now in terms of hardware, that is implemented in a microcontroller. So this goes to a microcontroller, and since this is the lower level control loop, I'm calling this lower level microcontroller. Now, in most cases, this doesn't directly give commands to motors, but there is a motor driver in between. And this is where the mystery returns. Why do we need a motor driver? And the simple answer for that is, the simplest way to think about it is, microcontrollers operate in low voltage regimes, whereas motors you typically need higher voltages, and motor driver is a translator in between, where it's looking at what are the decisions taken by the lower level microcontroller, but pulling higher voltage from a power supply. and then supplying it to the motor. That's essentially what a motor driver does. And for typical lower level controllers, you might have maybe used already some lower level controllers like Arduino boards. What are the typical kind of commands that go to a motor driver? The most common one is you just do PWM and polarity. Now, what is PWM? This is something for you to look up, pulse width modulated signal, and you can look that up. Now, the lower level microcontroller also needs some power supply, and there are many different configurations in which power is supplied there. Sometimes there is, from power supply there's a converter, then you supply a certain voltage to the microcontroller, or sometimes it's also from the motor driver. So there are multiple options here, and depending on the power supply and the controller, any one of those could work. But for the moment, let me just show this option where there is some power going to the microcontroller. Okay, now this is what is happening at the motor level, but then from the robot we now start to look at the higher level controller. This robot is again physically connected to, let's say, an encoder which is measuring all the joint angles, which in our control block diagram we called Q, the joint angles Q. So these are reading the joint angles, and this information is sensed, it's sensed by the encoder, and it's sent back to a higher level controller. Now, this higher level controller may also have an external input of what the desired actions of the robot are. And this higher level controller is then telling the lower level controller what sort of actions need to be carried out at the motor level. There's one more element missing here, which is your own computer, your own laptop, right? So we can think of that as an external element, a computer sitting out here, and you are using your computer to write code to both the lower level microcontroller and the higher level controller. So let me show these as different arrows. And the reason I'm showing them as different arrows that are not connected to the blocks is because this need not be connected all the time, right? So you are writing code and then uploading the code on the controllers, and once that is done, you can disconnect the computer and the rest of the robot can still work. I think this gives a reasonable idea of the key elements in the hardware setup of a robot and how they work together to control the robot.